So that's it. These are coordinates. So okay. So no need. Area by coordinates. Area by coordinates. If something is a fixed something fixed 0 0 line, you see taken as 0 0. Something irregular, something any irregular shape. To take something, take anything, take anything. Just start with something. X1 y1, x2 y2, x3 y3, x4 5 y4. The coordinates are given. The coordinates are given. So can you calculate the area? It's just mathematics. So I no need to explain. So if you take in the formula, so what is the area? You take in the coordinates. So half of y1. So x2 minus xn last. So y2. So those are the remaining x3 minus x1, y3, x4 minus x2. To write it like x4, x5 minus x3, like this. Yn last, x1 minus xn minus 1. First and last coordinates only changes. This xn will come, this is x1 will come. That is the formula. You know it, otherwise search it. Just a mathematics proof. Okay, just this is a mathematics. So like this we can calculate the area of, if you know the coordinates. So how can we know the coordinates? So I already said, if you're using the GPS survey or total station survey, you have to identify each point as the coordinates from the fixed reference. Then we noted the coordinates of the every points or control points. So if you know the control points coordinates, then you can easily calculate it. So no problem. I will solve one question, one problem. So same problem. Yesterday what we did. We can calculate the same thing. Okay, same thing. It's okay. I will same thing. So okay. Wait. This thing is somewhat. So what is there? somewhere bottom. So, copy paste this to okay. I will write same question once again. It's too difficult. Copy paste. Okay. So see this yesterday's problem. Side latitude departure. Okay. So AB is north, south, east, west. So AB is north, not it, east 4, BC north 15, east 249, CD west 120, so south 120, east once again 4, DA so north 0, west 257. Okay, this is the problem. So how can you get coordinates? How can you get the coordinates? How? Just write it simple. Just write yesterday what we did. Just we fix that something. So see it is. So north 108, east 4. So how can it will go? It will go like this now. So that means so this is 108, this is 4. Sample diagram. Yesterday already we drawn it. Okay. So next BC latitude is 515 again north and where departure is 249. So that will come. Understood? Just if you see it is northwise. Northwise now. So we already know latitudes and departures. This is 15. It's a 249 departure eastwise now. So next is southwise 123, eastwise is 4. Again eastward. So again eastward means it will come like again eastward. Okay, again eastward. So if you see it is 4, it is 123. Southwise na? Sorry. Sample diagram 123. Just a rough diagram. So later northwise is 0 and westwise is 257. So that's it. It's a 0. It's a 257 sample diagram. So where are the coordinates? So coordinates are come with a fixed reference point. So I will fix that. I will take that as something. I will choose like how can I choose? See this. How can I choose it? This is A. This is B. C. D. A. I will fix that. This is the AB line. So I feel that A has a coordinates of 0, 0. no problem. If you take in 0, 0, the calculations are maybe some problem, because if one thing is you put to 0, the total will collapse into 0. So that's why no need. So if you're choosing the coordinates, a fixed reference point, choose a particular number, not a 0, 0. Okay. To take a 0, 0 also, I think you can get answer, but I prefer choose something 100, 100, something, any of fixed reference, anything. No need to fix 100, 100. No, we calculate the inside of the coordinates. So with the reference of this one point, we calculate the remaining points. With the reference of one point, we calculate the remaining points. Then no difference at all. If you choose 50, 50, 100, 100, 0, 0, 50, 50, anything, no problem at all. No problem at all. So not only 50, 100, 100. If you choose 100, 50, two different values also, no problem, because it's just a simple mathematics, like graph paper. To take one reference point, no problem. Say just assume one reference. So see it is. If I assume 100, 100, this is the A point. What is the point of B? What is the point of B? So from 100 to how much increases? 108. So automatically it will come 208. So okay, no problem. If it is X is, this is X, this is Y. If you take in this is X and Y. So now what is the point of B? What is the point of B? So point of B is 104, 104 and 20. See it is 208. That's it. That's it. This is, if you take this is 100, 100. What is the point of B? So automatically X 104 and Y is 208. So later what is the C? So what is the C? So from this point to this point, so 208. So 208 and 15, what is that value? 223. So 223, that is the Y value. X value 208. See 104 plus 249, how much it is? 353. That's it. Coordinates. Sir, I don't know how it is coordinates. Join elementary school, 6th class, I think. Just you have an idea of graph paper. Graph paper, no? So just coordinates. Just I choose one reference point. Later I will give the location points. Okay, because this line has latitude 108, departure 4. That's it. Okay. So what is the D point? What is the D point here? See it is. So 353 X point. X. See what is the X point? Once again it's a increasing of 4. So 357. Why? It's a decreasing. Decreasing how much? 123. To decrease 223 minus 123, it's I think 100. Right? Because this is the X line. Same line. Same line. So that's it now. That's it. A, B, C, D coordinates are there. If you want to find out the area inside of between those coordinate points, that's it. Just what is the area? What is the area? Area you can write it of y1 x2 minus xn. So that is the one thing value. Remaining is y2 x3 minus x1. So goes on, will come yn x1 minus xn minus 1. This is the formula. Just you see it is, we have only 4 coordinates. Only 4 coordinates. y1 x2 minus x4, y2 x3 minus x1, y3 x4 minus x2, last y4 become x1 minus x3. That's it now. That's it. Only 4 coordinates are there. Just very simple formula. So take it as directly take of y1. So take it as there. It is x1 y1, x2 y2, x3 y3, x4 y4. You have to choose coordinates in a one sequence. One sequence. It's a closed, not closed traverse. Go by 1 1 1. It's something like. So start with any point. Go 1 2 3 4 5. Start with one clockwise or anti-clockwise. Nothing. But start, if you just choose this is x1, this is x2, this is x3, this is not a formula. Okay, this is not suitable. So choose one thing from one side. Okay, that will get this is the formula. Okay, so what is the value? y1 is 100. What is x2? x2 is 104. So what is x2? So it is, so what is x2? x2 is 102. y2 is x2. So x2 is 102. x2 is 102 minus x4 is what? x4 is what? x4 is something 257. Okay, 257. 104, 257. y2 is 208. x3 is 353. So x1 is 100. So like this. So what is the area? So if you choose, you could find out, this will come 291 meter square. Maybe positive or negative. There is no negative area. So no problem at all if we get a negative or positive, no problem at all. Okay? So that is the area. So what we get yesterday? So 221. So same thing you will get. Understood? Same thing you will get. So okay, so that is the by coordinates. If you know the latitudes and departures, you can easily calculate coordinates with reference to one point. Okay, so take one reference point like this. Okay, so somewhere 0 0 is somewhere here. So this is 0 0. You can feel it is. This is 100 100. I just feel it. So later we fix the coordinates and find out the area. Okay, so any number of sides, no problem at all. Any number of sides, no problem at all. So if you know the length and angle or bearing, you can easily find out the latitudes and departures. Are understood? If you know the length, if you have bearing, if you know the bearing, so you can easily find out the latitudes and departures of every line. So based on that, you can fix the coordinates of, okay, just length and bearing. So we did in a compass survey, length and bearing, forward bearing, okay, fore bearing and back bearings. So included angle. So we all discussed in the first unit of survey 1. Okay, that's it. That's the end of the story. So okay, by our areas, to calculate the areas is, so what we discussed 3-4 classes, areas divided into triangles, that is one easy, by offsets to the baseline, mid-ordinate method, trapezoidal rule, average rule and Simpson rule. These are all classification by mid-ordinate method. See, these are all classification by offsets to the baseline. Okay, so that's the one thing. We solved the problems regarding the trapezoidal rule and Simpson rule. Later, to find out the area by meridian methods. Meridian method and double meridian distances is the second method. You can call it as maybe third method. So later it's the area by coordinate system. Area by coordinate methods. Okay, that's the one thing. So next is areas only. Area by instruments. What is the instrument? If you draw a plan of something, that's a plan. If you draw a plan, this is the area. Sorry. To draw a plan, something irregular plan is there. If you draw a plan, then you can easily find out the area. How can sir easily find out the area? If you just draw in paper, if you just draw a plan in a paper, you can find out the area. How it is? So by planimeter, okay, by planimeter. So what is the planimeter? We discussed there. Okay, we discussed it. If you don't remember, I think you didn't remember, but check it is. We discussed the planimeter is an advanced equipment, how it is useful, how we have to use, how we will use to calculate the area. We already discussed, and I shown one video also. Okay, so this is a one planimeter instrument. Otherwise, I will show you once again what is that surveying one. So unit 6 cut tracer, plantograph, planimeter. We discussed it, no? Understood? Planimeter, this we discussed. So no need to discuss once again. This is the instrument, how it is work. See it is. We discussed planimeters, errors, how it is, integration, graph, what is the trace arm, trace point, anchor arm. I shown 2-3 videos also. 2-3 videos. Every instrument I explained. Every part. So what is the parts? How can we calculate it? And formula is there on formula. So not open, close. See it is. This is a formula. Right? We did everything. We did everything for planimeters. No need to discuss once again. Okay. So that is for one section. Second section also explained it. Pantograph. It's a planimeter. For another section. So at the time 2 different classes are taken for 2 different sections, batches. So see it is. We write it. Okay, planimeter. So that's it. No need to explain once again what is the basic principle in planimeters, what is the digital readings, how many circles, what are the parts, and I shown 1-2 videos also how they measured. I think one guy measured the map, the textbook map, na? So map, he measured a one lake area. I think just recollect it. And one guy in a chart, he measured something area. So okay, so that's it. So that's the story. So that's the area by instruments. Advanced instruments is a planimeter. So no need to discuss again. So that's the story of areas. That's the story of areas. Okay. So remaining also everything just using up the mathematics now. So you can choose your personal methods. No problem at all. These are the just small methods. They just explained. So no need to follow only by these methods only. You can follow your methods because you know the mathematics. You know what is mean by area. So if you know the idea of this shape, how can we find out the area without much error? See, with very small errors. Error is common. So you choose your methods based on your basic knowledge in mathematics or integrations. So you can choose your methods. So I think you know your mathematics. You measure the areas. How can you measure the areas? Measure the areas by fx. So line equation. If you line the equation, if you know the equation of the line, so by the integration of a to b, you will get area. Understood? If you know, see it is. If you know this is the area. This is the line equation. So what is the line equation? It has y equal to 3. So y equal to 3. That means y minus 3 is equal to 0. That is the area equation. So based on the area line equation, integral from 0 to, so x is 0 to 3. X is equal to 0 to 3. That's it. So double integration, triple integration, surface integration, volume integrations. You get it? So many methods are there, but we simple in surveying is not only surveying, civil engineering, simple areas. No need complications. Okay. We explained very small basics. If you feel you can get a very good approximation of the value by your own method, choose it, no problem at all. And also, if I am giving the problem in it, if I give in the mid examination any problem to calculate the volume or to calculate the area, so no need to follow some methods. If you have good mathematics knowledge or good aptitude, you can choose your method. You can find out the area. It will get, if you get a very good approximation, then it will be okay, no problem at all. So that is your aptitude level. I am expecting that level. No need to follow Magappa formula, something. Okay, that's it. That's the story of the areas. So now we will go to the volumes. Same volumes. What is the volume? Area into height or distance. That's it now. What is volume? Sir, why we need to calculate the volumes? In a civil engineering problem, we have to find out the volumes, not a flat areas. Now we have to find out the volumes. Why, sir? So every section, see it is, we already discussed first day. What is the purpose of to calculate the volumes? See it is. So canals, embankments. See it is. Canals, embankments. So cutting and filling. So cutting and filling. See, something canal is, we have to dig a canal. So something canal is there. Canal has something length. Something canal. So you have to find out the volume of the canal. So volume of the canal means how much length is there. So we have to integrate. See, we have to divide by the sections. Sections 1, 2, 3, 4 sections. Later we can calculate every zone volume. So every zone volume means this is. So you can take this volume, this area multiply with distance. Area multiply with the distance, you will get volume. That's it now. So same thing, no problem, no nothing. Previous methods we just taken one. See, previous we just take one line. So 1 degree higher. So just taken one higher, one something. This is a distance. One height. We just taken one height and interval distance. We will get area. Now we will choose same thing. So now not only we taken one element, one not a single degree. It will taken one area. So just this is the area. So if we taken this. So now we will took the area of the portion multiply with interval distance. We will get volume 1 degree higher. Just 1 degree higher. Previous we took one linear element distance, height. So let multiply with interval distance, we will get the area. But now we will took area multiply with interval distance, we will get volume. Okay. So nothing. Same methods, no problem at all. But we need to find out where the volumes are important. So not only canals, road works, see it is, canals, road works. So transportation. So how we will make roads, highway roads, anything. So we have to maintain a payments. So okay. So how much we have to dig it? Otherwise, if you something, any slopes are there, something. We have to maintain a same level, uniform level. We have to fill the gap. So you may also see this. If you construct a house, anything, we have to maintain certain level. So we fill the earthwork. We fill the earth. Otherwise, see it is. We just somewhere we put earthwork or sand or something. We just taken from another place and we just landed it on our place, and we will maintain uniform level. Understood? We maintain uniform level. So how much earth, how much sand we require. So how much sand we require means what? So again, if you know the volume, we can get from another place. So that is the contract system works now. So you have to maintain records. First, you have to maintain records. How much earthwork is required? How much sand we require? So how much sand we require means what? What are the works we are going to be do? So later, so what are the each work divided into each work and how much sand we require to maintain each small intervals. So we calculate the volumes of earthwork we require. So now also, if I already said now, so some of the instruments, not instruments, some of the equipments, bulldozer, dozers, these are all operated. These are all operated by how much earthwork you have to do, how much earthwork to be done. Based on that only we will give the money. So certain 50 meter cube, 50 meter cube of earthwork we have to done. So that means what? 50 meter cube of earth, something sand. So to locate from this place to this place, and we fill it. Based on that tractors, and workmen, these are all decided by the contractor. How many trucks we required? How many trucks we require to gather the earthwork and coming to our place and land it. So how much earthwork he is done, based on that only we will assign a money. So everything in every place we require how much of volume we require. What is the volume? What is the volume of that work? In every place. See, it is, if you see some embankments. See, I already said, if you see the embankments, if something, so Anakatta antaru kada, Anakatta. See, this is the embankments. These are the embankments. So you have to place like this. So we write like this. So get it. Understand? So this way. So total how much of earthwork we required. So this is the area. Understood? This is the area. So total volume we required means what? We will divide into intervals. So this is the one area, A1. Multiply with H. You will get volume. But this is not exactly symmetrical. A1 into H, no. So we will use same thing. So last time previously we used something. So this is x1. So I think O0, O1, O2. This is H. So total area, not O1 into H. Total area we will divide into O0 plus O1 by 2 multiply with H. Average alternate method, middle alternate method, trapezoidal. Same thing we applied it, but now its O0 is replaced by A1. Remaining is everything is okay. Okay. So that's why we will proceed. And also remaining, you see, it is for some position, some places you have to fill. So in the roadsides, if you see the roadside, so if you see, if it is a road, it's like it's a road. Sorry, it is a road. It is a road. So roadside sides. So you have to maintain certain slope, na? You have to maintain certain slope. So I can't write it. You can maintain certain slope, na? So you fill earthwork. Understood? You fill the earthwork. Certain slope you have to maintain, because if your vehicle is passing on this vehicle, so maybe in the besides of the road, maybe some. So earth is broken, not earth. Soil is broken, may chances. So you have to fill besides the roads also. If you see anything, if railway track is there, you just see, observe it. Some slant slope is there, no? Maintain some slant slope. You have to same thing also. That is also same thing. Some slant slope is there. Understood? So that's it. And also for a visiting place, not for a recreation clubs or something, anything, just to sit down and lay down, and enjoying places. So you have to something see it is something like something you have to fill like something you have to fill up. So do you have to maintain certain slope just sitting and enjoying the locations? These are all embankments, okay, but support of these are the retaining wall. Maybe this is the retaining wall. So to support the retaining wall, we have to maintain earthwork. So okay, so to fill that gap, certain height. Okay, so these are the filling something. So if you observe it, the area should not be exactly in the same area. May be changes with respect to the structure. Maybe it has some slope. It is not an exactly B into H area. So maybe area has some slopes. Maybe this has a trapezoidal. Maybe trapezoidal slope are there. So first you have to find out the each area. First you have to find out the area A1 and A2, A3 each location. So like that O0, O1, O2 like this. You have to find out the each location, each intersection, each interval. At the location of each interval, we have to find out the areas. Then we can sum up areas into interval distance. We will get volume. First we have to find out the areas at each locations. What we decide something with each intersection locations. But may see it is the area may not be equal to the every location. Area may be changed. Maybe certain distance we provide certain area. Later we can increase the area because maybe ground, something in the ground, some very porosity land is there. We have to fill, we have to maintain it. So large amount of earthwork is we have to do. Maybe we don't know. So like this, you see. First, if you know the area of each section, then proceeding multiply with the distance is very easy. So how many different types of areas are there? Each location. If you see, first maybe this area is there. This area is there. Maybe very small, very uniformly. So if you go to this, we go to this, we go to this. So this is the area. At every location, maybe area is same. Maybe it's same. See this? This is area, this is area, this area. Every location is same. Maybe that is a possibility. If you see the canals, not a canals, water pipes. If you see the water pipes, so pipe has area. Every section has same equation, same area. Understood? And the circular area, that is a circular area. So that's not an important surveying. So delete it. So maybe in some zones, area may be in trapezoidal section. Area may be in trapezoidal section. If you see the canals, almost all are in the shape of trapezoidal shape. Almost all are in the shape of trapezoidal shape. Are observed? I think water is open channel flow. I think it's going on. So what is the area of the section? If you see it is mostly areas are in trapezoidal shape. Why it is maintained to trapezoidal shape, not in rectangular shape? What is the importance of trapezoidal shape? So they will explain the open channel flow. What is the something energy methods, total energy, potential energy, kinetic energy. They already know. So what is the economical section? Most economical section. These are all going on fluid mechanics. Open channel flow I think just started I think. Okay. So that is the trapezoidal sections are there. In some recreation clubs are retaining. So to maintain the retaining wall, something like this will give. This is okay, trapezoidal good, but this has two different subsides. This is the same. This is called two level section. Two level sections. So two level section. This is called level section. This is called level section. One level. So means it has same slope. It has the same slope. So both two levels, this level, this level, this is only one level na? From this ground point. So this is the same thing, bottom. From bottom, top has only one level, so maybe 5 meters, some h level, only one level. But if you take in this, so from this it has one level, it has another level, so one point to another point, it maintains some slope, so that calls it's a two level section. Maybe if it is some retaining wall is there, something any purpose, so some different purposes, it is a ground. You have to maintain like this to reduce the earthwork. So in this section you can maintain from this level also, but it is also safe. Then we can reduce the earthwork we have to be done, so we can reduce the money. Okay, this is a two level section. Some places, if you see some places, maybe like this are there, like this, like it's a ground. But if you see it is not a safe. If you put like this, maintaining a retaining wall, this is not a safe. So safe, it is not a safe slope. You can easily collapse it. So now what we will do? We will do like, see it is. We will do like, we maintain. So what is that means is, you just these are the cutting. This is a cutting. This is a filling. This is a cutting and this filling. Maybe so many. Somewhere you have to dig it. Somewhere you have to fill it. These are all part and parcel of surveying. Some places are you have to dig it. Some places are you have to fill it. Okay, I understood. So that's it. So many shapes are there. So many shapes are there. So we have to calculate the areas of different sections. Later we can multiply with interval distance. You can get volume. That's not a big deal. But find out the area. So we will already discuss to find out the areas. How we will find out the areas? We already discussed now. It's just over now. It's a irregular shape. Just we discussed. This is a irregular shape. It's a irregular shape. How can we find out the area? We already completed. Now, if you know the area of this section, later it will expand it. This you can find out the wall. You know the area, then you can find out easily the volume. So if you see if it is the same thing, this is the area of A1, this is the area of A2, this is the area of A3. So like this. So you have to find out the total volume. How can you? Same again, trapezoidal rule, Simpson rule. Understood? So if you know the area of this section, so if you see it in three-dimensional view, like this. This is the area 1. So this is the area 2. This is the area 2. This is area 3. Understood? So you have to maintain. Understood? That is the volume. We have to find out the total volume. Just we decide area 1, area 2, area 3. So interval distance h1, h2 or h something. Interval distance h. So you can use Simpson rule, trapezoidal rule. You can find out the volume. Understood? So same thing. Already we use it, trapezoidal rule, Simpson rule. First we have to find out the area. But we already discussed how can we calculate the area. How we will calculate the area. So that's it. Later we will use the same trapezoidal Simpson rule. We will get the volume of the total earthwork. So, okay, that's it. In a transverse, in the syllabus they mention it as transfer slope, with transfer slope or without transfer slope. If you see there is no slope. It's just a rectangular shape. So to find out that area, not a big deal. P into H, it will get area. So what is the big deal? Big deal has a transfer slope. This is the slope. Understood? Transverse slope. So most of the channels are reverse. Anything, most likely into this shape, trapezoidal shape. So how can you find out this area? So you can easily find out. So we will explain tomorrow. That is not a big deal. It's a common, very small. So this has a transverse slope. So this is, see it is it has a transfer slope. If it has a transfer slope, how we will proceed? How we will proceed to find out the volume? Next class we will discuss. Okay, that's it. So what is the today's task is, what is the importance to find out the volumes in our surveying? What is the importance to find out the volumes in our surveying? So how many different shapes are there, and different where locations are in different fields where we want to find out the volumes, discuss just now. So that's it. So in different shapes and different positions, not a positions, different field works, different situations, different cross sections, different areas will come. So to find out the area, multiply with the interval distance, we will get volume. That's it. That's the enough story. Okay. So I had shown you the different shapes: two level section, two level section, cutting and filling, embankments, rivers, canals, roadworks. These are all the places we have to find out the volume, or what is the total earthwork we have to do. So that's it. So next class we will see very small problems. How we will proceed to find out the volume series. So that's it. That's the story of today. So later we will discuss one thing.